Inside a semiconductor, a P-N junction is an interface or a border between two semiconductor material types, namely the P-type and the N-type. When we utilize various semiconductor materials to form a P-N junction, there will be a grain boundary that will prevent electrons from moving from one side to the other by scattering electrons and holes, which is why we employ the doping procedure. The semiconductor's P side, or positive side, has an excess of holes, whereas the N side, or negative side, has an excess of electrons. The doping process is used to produce the P-N junction in a semiconductor. The P-N junction is said to be forward biased when the P-type is connected to the positive terminal of the battery and the N-type to the negative terminal. The built-in electric field at the P-N junction and the applied electric field are in opposing directions when the P-N junction is forward biased. The P-N junction is said to be reverse biased when the P-type is linked to the negative terminal of the battery and the N-type is attached to the positive side. The applied electric field and the built-in electric field are both in the same direction in this situation. A curve between the voltage and current across the circuit defines the properties of P-N junction diodes. The x-axis represents voltage, while the y-axis represents current. The characteristics curve of the P-N junction diode is shown in the graph above. With the help of the curve, we can see that the diode works in three different areas. Applications of P-N junction diode. When the P-N junction diode's arrangement is reverse biased, the diode may be utilized as a photodiode since it is sensitive to light. It has the potential to be utilized as a solar cell. The diode can be utilized in LED lighting applications when it is forward biased. Many electric circuits utilize it as a rectifier, while varactors employ it as a voltage-controlled oscillator.